Only the DP of Vasudev and Ishita, right?
So I've been trying to get it to record my screen, but I do not know why. It's just not working. It records the screen, but it doesn't record the audio. One thing that I could do was it would be to rely on Skype for the audio and my desktop recording for the video, and then club them both together. Yes, I could do that.
Okay. I hope it works. Please do.
But the thing is, it's pretty time consuming, and I also have to re-encode the entire video file.
You do you have time. You have time for other productive work to be done. So what can we do best is at least some part of the session should be recorded. In that case, both of you ought to be on your video camera on with the
Yes,
mode of video camera being switched on.
I am on camera.
Shita,
Yes, sir.
Vasudev, you may record certain part of it.
Yes, sir, I am recording.
Vasudev, let's start with the process that I want you to be taken through, and that being few questions which I may show. Few questions which I may have. Yeah. On EMI. Questions which I do have on EMI. So I need to take a few from IRDO. If you have been through them, good. If you have not been through any of the question of IRDO, I would suggest start solving IRDO. And if you have been for long with IRDO, then I wish take few questions which you have your doubts in for quite some time now. Do you have any doubt related to any of the question on induction IRDO, Vasudev?
So not now yet. I've tried a few questions and I've been able to solve them with relative ease.
Did you figure it out? The question that you did ask me the other on spread for infinite action. Will you feel that I by R?
Sir, I'm afraid I'll have to stop you. I can't hear what you're saying.
That
So your video is frozen and we can't hear what you're saying.
I can't hear you.
Just a minute, I'm changing the network. Can you hear me now?
Yes, so we can hear you. We did, but your video is frozen again.
You may not be able to see owing to there being a park. Anilak? Anilak? Vasudev and Anilak, are you able to see?
No, sir, it's a black screen. We
I'm
can't
not.
see it.
It's a black screen going to there being a park at. Am I audible?
Yes, sir, you are.
I'm audible, right?
Yes, sir.
In that case, if you have not solved any question, Ishita, which I think is the case, you may not have solved questions. So will you be initiating with IRDO?
Okay, I would solve.
Yeah. Please see to it that you have initiated with Iredove. Okay. Vasudeb, please start recording now. I think I'm clear. It's visible or being restored, right?
Yes, sir.
So I was referring to a question which is what being cited in I'm making it first visible to you what the question is all about by drawing it on the board. This is what they have. There is inclined, there is an inclined, and there is a connector. They have marked the angle theta, which is what being marked. The side view. Okay. So this is a structure given to you, mass M, length L. Check it out. Mass M, length L, capacitance C, free to slide on the rails. Now what being asked? Asked is acceleration of this connector. I repeat.
Ishita, did you get what he was saying?
Acceleration of the connector.
Sir,
Find acceleration of the connector.
sir, I'm sorry, sir. Could you repeat the question statement? We didn't hear it.
Sure. I repeat. There is a connector free to slide on the rails. There is a connector free to slide on the rails. Capacitor C is connected to network as shown. Theta being the angle of inclination. Theta being the angle of inclination. Find acceleration of the connector. Find acceleration of the connector. Mass of connector being M, length L. Mass of connector being M, length L. Of course, there is a B field, and B to show is acting in this direction. This is the side view which I have shown. This is the direction of B field. Please do check. Are you good with the question body? The body of question, is it clear to both of you? Or shall I repeat? Is the body of question clear?
So the B field is acting upwards.
Come again, dear?
B field is directed upwards.
Yes, it is.
So then what are we to find?
Let the acceleration The acceleration in terms of givens. So the givens being C, M, L, B. These are the givens. C, M, L, B. This is the given set of parameters. Anyway, we have to deliberate, Vasudev, then to go for a solution. I need to deliberate on this question. So I wish ask, what will happen initially? Both of you. Question goes to both of you. What will happen initially? Known to you that the capacitor isn't charged. Known to you that initially there will be no current which is to flow. By the way, why I say so? Initially there will be no current flowing. Please, if you endorse, make it amply clear to me. No current will flow. Current will get initiated owing to certain change. Can you reflect on that change, Ishita? Can you reflect on that change? Ishita, you're not being captured by camera, dear. Your camera is focusing somewhere else. Yeah. Ishita, what is to happen initially?
Yes, sir. I was looking.
Initially, the slider will move down. Vasudev, are you on the same page with this?
Yes, sir.
And when slider moves down, Vasudev, what changes?
Flux through the loop.
Flux linking through square or rectangular segment loop will change. Courtesy this change, EMF will get induced. EMF will get induced. Let me make it amply clear to both of you. EMF will get induced whenever flux is changing. Current is the byproduct. Current is the byproduct. Current may flow or not. That is a different ball game altogether. If you channelize, current will flow, but EMF will get established whether you are in your free will to exercise, there being no or total, whatever be the scenario. If there is change in flux linking through any area, EMF will get induced, and it is not beholden by conductor. EMF will get induced even in air. So when you view from top, in which direction will current start flowing? I repeat, when you view from top, in which direction will current start circulating? Or to be precise, in which sense current will get established?
Clockwise?
When you're viewing from top clockwise, what say you, Ishita? When you view from top, current will get established in which direction? Clockwise, anti-clockwise. Vasudev went with clockwise. I'll come to him to reason it out. Before of it, what is your take, Ishita? Clockwise, anti-clockwise? From top, B field upwards. Vasudev, why clockwise?
So the slider thing is moving down. So the net flux directed upwards is increasing. That should result in that's a result in a current that induces a magnetic field in the opposite direction, that's downwards. And if you just use the right-hand thumb rule from there, you get clockwise.
Absolutely right. You are abject on it. Yes, it'll be clockwise. Why? Because we are to compensate for increasing flux through increasing area. Correct? So current as seen from top will get established in the direction clockwise. Is it okay, Shita?
Okay.
Okay, so current got established. Let me show current direction here. Current is in this direction. And if velocity is v at any point in time, we know that velocity will keep on changing. As of now, it is v, let us say. then what potential will get established across the ends of this slider known to both of you? What will it be? What will it be, Vasudev? What potential will get developed across the ends? Could you please come again?
So just 1 second. Press B.
Please establish it. We have interaction. Your equipment is 2021, so you are an old equipment, older than Vasudev. Right?
So
Right
BBL
there, Siddha. Yes, Vasudev, you were saying something. Sorry. Yeah, please continue.
BBL sine theta.
BBL sine theta. Okay. What is the angle between V and B? What is the angle between V and B? Angle between V and B is 90 plus theta, right?
Oh, yes.
Angle between V and B will be 90 plus theta. This remind you, this is the direction of V and this is B. So angle between V and B 90 degrees.
Yes, sir.
And angle between VB or V cross B and L is 0 degree, correct?
Yes, sir.
So what do we get from here? V cross B will be marked as VB sine of the angle 90 plus theta. And L will incorporate later, correct? V cross B will be marked as VB sine of the angle 90 plus theta, which is what to get us? Which is to get us VB cos of the angle theta whole into L. So we got this. Fine, this being the potential, which end is to be high, which end low is a no-brainer. You are aware of it. So I mark it for you. This pad replacement or cell replacement. This is a cell for us. VBL cos theta and the cell. This is the cell here. This is the cell.
Yes.
Okay. Which end will be positive, which negative? I presume that is apparent from here. V cross B. V cross B pushing it towards us. So our end is positive. This is the end which we are facing, and this is away from us.
Yes, sir.
Okay, next what we should do. Yes, I want some spunk over here, Vasudev, as you have been carrying. Help me out. There are many unknowns over here. You are aware of. We want A. So what should come to me over here is someone to tell me, any one of you. What should come to me? What should catch my fancy now? If I'm to factor in acceleration, what should fancy?
So the force on the wire due to the current it's carrying, the Lorentz force.
What should fancy the teacher? Being a teacher, what should I fancy is bring in acceleration, and that best I can do by roping in which equation? Newton's second law of motion, right? Yeah. Okay. I have to get an acceleration here, right?
Yes, sir. Sure.
What should I fancy on? I said fancy on Newton's second law of motion, correct?
Yes, sir.
What should I do then? What is the force for the downward? Again, what is the other force if I is the current taken at any arbitrary position? Any arbitrary position of rod, if I is current flowing through it, then what force it will be subjected to owing to B field presence? I will flow in which direction? I will flow towards me in the rod. This is the rod that I am in. I will flow towards me, right? I will flow towards me. Say me yes or no?
Yes, sir.
I flowing towards me. So if I is flowing towards me and B is upwards, please do check there. Then angle between B and I is 90 degrees, correct?
Yes.
Angle between B and I, please be mindful, angle between B and I, 90 degrees. L cross B will be in which direction? We take L in the direction of current. That means L is towards me, B is upwards. So L cross B will be in which direction? Tell me, dear.
To the left.
Okay, to the left. Let me show it to you. This is the direction, therefore, for force ILB, right? ILB, LB angle 90 degree, B is in the board, L is perpendicular to it in direction of current. So angle known to you 90 degree, ILB is this to us. What then I should incorporate over here? MG minus what? MG sin theta minus what? MG sin theta minus of ILB cos theta, agreed?
Yes, sir.
So MG sin theta marked already, minus of ILB cos theta. Minus of ILB cos theta. What is this to be? This to be equated to mass and acceleration ma. Do check there. Mg sin theta minus ILB is equal to ma. I presume so far so good. Now to the unknowns. I have two unknowns in my eventual equation. One is I and the other A. I require one more equation mathematically to make it feasible or solvable. I require one more equation. Who is to help me with that equation? Who is to help me with that equation? Come on, dear, I need your help. What to do? Tell me, dear. Tell me, Vasudev. What shall I do?
I'm assuming it's something to do with the capacitor because we haven't touched that.
Of course, otherwise it doesn't, it's divorce of sense, it doesn't cut through. Why the capacitor on earth there? So what relates to capacitor is KVL, Kirchhoff's voltage law, right here. We can loop it, we can assume Q the charge, any arbitrary position Q the charge, and then can write KVL, Kirchhoff's voltage law, which is what to read? Minus of VBL cos theta plus of Q by C is equal to 0. Do check.
So, but there you're assuming the capacitor is fully charged.
No, I'm not assuming capacitor to be fully charged. I said any arbitrary position. The moment capacitor is fully charged, I will reduce to 0, dear. I cannot take capacitor to be fully charged. Certainly, this equation is arbitrary. By that, what I mean, it is function of time. This is not to help me, but what will have is the differentiation of this equation. Is the differentiation of this equation. Differentiated with time. When you differentiate it over time, what do we get? Minus of ABL cos theta plus of I by C equal to 0, and this suffices. This is equation 2 for us. Previous being equation 1, this 2, with the help of 1 and 2, we get what required. We get A. Tell me about A from here, please. Substitute I, get A. Substitute for I, get A, and please walk yourself through this problem. In piecemeals, this question has got a knack to feature even in a regular examination. When you talk of small time every day, it is a must. It's a given. So what is it? The final, please.
So I got the final answer, but I have a doubt in the KVL equation you assumed. My point is, at a certain moment in time when it has a velocity v, it has a potential vbl cos theta, right?
Correct.
And you're assuming the entirety of that potential drops across the capacitor.
Correct.
So the capacitor at that moment in time must have the charge Q so that it has the required amount of potential.
Correct.
All right. So the V also builds up gradually from zero, right? I mean, the V
Yes.
starts at zero and then goes up. Yeah, fine. All right, then I can accept the charge buildup.
You can work for the other question, which will be bringing clarity on the one which you are. I presume you are having some inkling on what will happen on energy scale, right?
Yeah. I mean, usually when we think about charging a capacitor, it's against a constant voltage. Here, the potential difference itself is changing.
Right. Right. But the one that you have, this is an important question, which is over here being shown, a self-shown question. And to do more on the question which you are trying to hint me on, I wish to take another question from IRDO, wherein they have given you that you are supposed to maintain velocity of slider. You are supposed to maintain velocity of slider and they have replaced capacitor by resistor. They will come to an expression which will equate energy lost in resistor equal to work done by gravitational force. We can prove it.
So similarly here, can you say work done by gravitational force is equal to the energy stored in the capacitor?
Work done by gravitational force is equal to energy lost in resistor. Only then velocity can be maintained. Correct? Yeah.
Yes.
So there we do prove it. I'll come to that question. I wish here highlight a question which has got some ambiguity vis-a-vis answer in IE-RODO. Next question which I am to take has got some ambiguity vis-a-vis answer in IE-RODO. There is some typographical error, I would say, not conceptual, but typographical error. So we need to tweak answer. Before we are qualifying tweak answer, let's substantiate change with theoretical examination. So the question goes as follows. Write down. A rod of mass m length L. A rod of mass m length L is rotated with constant angular speed omega. A rod of mass m length L is rotated with constant angular speed omega. Find equation of EMF as function of time to facilitate this motion. As function of time to facilitate this motion. By facilitating this motion, what I mean, class, is providing constant angular speed omega. I repeat, what I mean is providing constant angular speed omega. Mass m, length L, B field B, EMF on which the question is positioned as a symbol to its merit E.
So could you draw a diagram?
Clear with the question, Ishita? Yeah, I'll be drawing for it. Ishita, am I clear with the question?
Yes, sir.
Okay, let's go for the diagram then. This is the circle which our two is present. This is the rod, mass of the rod M, length of the rod L. At any point in time, angle theta. B field directed into the green board. This is the E. Let me show you E here. Please check. E, theta with the horizontal, mass M, length L, B is into the board.
So what's the vertical protruding structure you've drawn?
E, this one.
Okay.
This is to facilitate flow of current through the rod. This E will facilitate flow of current through the rod. And the caveat or the premise that we begin with, the rod is to move with constant angular speed omega. In angular speed of rod.
So let me just get this straight. So basically you're saying the EMF will induce a current in the rod, and that will result in a force due to the magnetic field, and that will turn the rod. And that's
there will be an EMF induced, no doubt about it. Why? Because the rod is in motion. But that is not the one responsible solo for flow of current. Also is responsible E, which is being shown over there, this E. This E is being extraneously provided, okay? This E is being extraneously provided. And that is what the question is positioned at. Find E as function of time. What criteria you are to meet? Omega constant. Rod should move with constant omega. That is the criteria to be fulfilled. Got it, yeah?
What is the agent rotating the rod in the first place?
How will the rod rotate? Why don't you tell me what? So you allow current to flow through it. Which direction you want current to flow through it? Let me ask you to let it flow outwards, let's say, this way. It's up and down, this should be positive, this should be negative to begin with, correct?
Yes.
So current started flowing in the sense showed as flows current. What will the rod experience being placed in B field known to both of you? None of
Yes.
you being a green horn, tell me what happened. There will be a force experienced by rod. Or if I may push the envelope, there will be a torque which will try rotate it in which sense. It is hinged at the center. Rod is hinged at the center here. Force in which direction? I, L cross B away. Force in which direction? I, L cross B. Tell me dear, can I show force? This way, perpendicular to the orientation of rod. L cross B, B inward, L outward. L cross B was in this direction, correct?
Yes, sir.
What about torque?
So,
Can we mark torque as ILB into L by 2?
so
Either
say
you take in piecemeal and integrate, or straight midway, as is the linear function.
So could you come again? I missed that.
Either you say it is a linear function, so the point of application can be taken midway. In the linear pressure equation, P is equal to P naught plus OGH. We used to get it midways, effective force midways. Either you take that from your notebook, or you take parts and integrate. You take in parts and integrate. You can find small torque on a small segment at a distance x, and then integrate. You'll get no exception. Okay, you'll get no exception. What you'll end up getting is ILB into L by 2. Please substantiate it. You may substantiate it. Take torque. If you wish to substantiate, take torque. What will be torque? Torque will be force. I'm taking a segment at distance x. So what will be force on it? I dxb. And what torque in accordance into x, correct? Take it out here. I dxb will be force, and what distance it is at? It is a distance x. So into x integrate, place it from 0 to L. You get no odd with this equation. ILB into L by 2. Would you approve of it? Would you approve of this being torque? Yes or no on the rod owing to current I flowing through it?
Yes, just 1 second. Let me confirm it. Explain to yes, sir. You get the same thing.
Okay, so this is torque. What is the other torque acting? No brainer. The other torque acting is due to mg.
Oh, so this is in the vertical plane.
Yeah, this is the upward direction or anti-clockwise sense.
Okay.
And mg will be in clockwise sense. What will that get us? mg L. Can we mark cos theta? L by 2 rather. mg L by 2 cos theta. Please do check.
Yes, sir.
mg L by 2 cos theta is equal to what to us? I 0. We have maintained omega, so alpha is 0, correct?
Yes, so we need zero net torque on the rod.
Yes. This would qualify first equation to us. This is our first. Now the second. What about second equation? Second equation. What will be potential difference if the rod is rotating with a speed v or angular speed omega? We are aware of b omega L square by 2, correct?
Yes, sir.
B omega L square by 2. V cross B in which direction? Not to you. V this way, B inward. So V cross B, descent will be positive to us and this negative, right?
Yes, sir.
B cross B, positive, negative. We write KVL now. Write KVL now. What is that to get us? Please tell me which direction you want to move. Just practically more cogent. Let me mark R, the resistance, with rod. Only rod, not periphery. Only rod. There is no periphery. You may discount on periphery per se. Or if there is periphery to be taken, assume no resistance with periphery. Else we'll have to add nothing much. Here I have to take R associated with rod in solo. R is the resistance. We wish to get from you KVL. I'm just going in tandem with what Iridov has asked. There is no R taken for periphery. KVL, please. Though we will not limit there, we will take R later. KVL, tell me. Minus of E.
So could you hold the camera steady?
Yeah, just a minute. Yeah.
Yes, sir. So the battery and the EMF generated by the rotating rod are in the opposite sense.
Correct, they are.
Okay.
Minus of E plus of B omega L square by 2 B omega L. I'm taking as length. B omega L square by 2 R I have taken as resistance associated with the rod. So what do I write next?
Minus
IR. Minus of IR. Is a plus. Plus of IR is equal to what to us? Is equal to 0. Plus of E plus of B omega L square by 2 plus of IR is equal to 0.
Yes.
Now you know what to do. Get me E, please. Just substitute I from equation 1 into get E.
So I think we can possibly skip the mundane algebra.
Yeah, right. We can. We'll be able to find E, correct?
Yes, sir.
I just wanted to correct the answer out there. You will be in a position to do the needful. Okay?
Yes, sir.
Need to ask anything? Vasudev seems distracted. What happened?
Yes, I actually had a bunch of doubts. Just
Yeah.
thought I'd send them to you. Yeah. Yes, I've sent one of them.
on two isolated point particle of masses m1, m2 in space are separated by distance d. Okay. Newtonian gravity is the only force through which they interact with the two isolated point particle, and Newtonian force is the only force. Find the time t after which collision of the particle take place. So collision of the particle over time. You have two masses over.
So I can't hear you. Can you come again, please?
Two masses separated by distance d, right? And the only force is Newtonian force due to gravity, gmm by r square, m1, m2 by r square, correct?
Yes, sir.
So at any point in time, you will assume separation between them as x.
Yes.
And then acceleration accordingly will be gm1 m2 by x square divided by m1 for a1 and divided by m2 for a2, correct?
Yes, sir. I got till there, but how do you exactly get the time? The acceleration is continuously changing.
Yes. Now you will take relative acceleration. You will assume one to be at rest. Both of them are to move, correct? Yeah.
Yes, sir.
So you'll assume you want to be at rest. Or to make it generic, let me tell you, F is equal to ma doesn't hold when you have masses comparable. What holds there is F is equal to mu A. It can be proved. Where what is mu? Mu is reduced mass. It is concept of higher physics. F is equal to mu A. It becomes F is equal to ma when one of the mass is very high on quantum in comparison to the other.
Yes, sir.
Okay? So F is equal to mu A you can take directly, and after taking F is equal to mu A, what we have to do, we have to write. By the way, what did you do after that? Why did you get stuck here? If up to this point you have gone, what happened after this?
So once you get the acceleration, you need to get the velocities as a function of time to actually find, and then from there you can integrate to get that distance as a function of time. From there you can find out we can plug in the distance and get the time which they took to travel that distance. Yes, that was my approach.
Yes, but you can represent acceleration per se in terms of x.
Yeah, well, essentially that's what we've done right now, right?
I have just marked MA. Yeah, MA I have marked. MA is equal to force. A we have gotten over here.
Yes.
A can be written as dV by dt or Vx into dVx by dx.
Yes, sir.
After of writing A as V into dV by dx, we can integrate for V, correct?
Yes, sir.
We'll get V as function of x, correct?
Yes.
After of getting V as function of x, we can now write Vx dx by dt.
Okay, yes, I see where you're going.
Okay. What I'm trying to suggest, A
Yes.
you got after V into dV by dx, then you get V as function of x, then after you write V dx by dt and integrate.
Yes, and once you get x as a function of time, we can just plug in the value of x and you get the time.
Exactly. This is akin to a question which I had long asked you in the class when the chain was given to you. And then was asked, what time will the chain take to slip off the table when the supporting cord is burned?
Yes, sir.
Exactly the same. You there over this block. Okay, will you be able to?
Yes, sir. I think I can take it from
Okay, here.
So, please repeat.
In the second half, okay?
So I didn't get you.
And if you first classes will be informed well in advance. It will be taken mostly in the, if you're morning and can accordingly be informed, we'll position it in the morning as well.
Yes, sir.
Okay.
And so could you arrange a better internet connection, stable camera holster? Because right now the video is very choppy.
Yeah.
And your voice just fades out
I do
very frequently.
apologize. I will